Okay. Since we are told to find this, obviously y is a function of x. So this is the product 1 comma and 2, right? The first function prime is 1 times sine y plus the first function times sine y, which is prime, times dy over dx minus sine x equals 3y squared dy over dx. We can't solve this equation for y. No one can. So we are asked to find dy over dx, meaning implicitly there is no other way. So because we are asked to find dy over dx, the first question or reminder to myself is, don't forget, y is a function of x. X is the, yes?
Sorry, I didn't.
No, no, that's okay. I talk too much anyway.
So when we do some problems, like maybe it's just because it's different types of problems, but we would have like the dy and dx separated based on.
Very good.
You know what I mean?
Yes. So if we are asked to find the differential of a function, then we will have to separate the two. dy equals f prime of x dx. Because separately they have a meaning, but they also have a meaning together. The meaning of together, dy over dx, is the derivative of the function, a different notation.
Right.
But separately, dy is the change in y triggered by a change in x, but using the derivative, not the actual values. But it's useful because it approximates the difference, the exact difference in y produced by a tiny error in x.
Like I get the difference between them apart and separate. I guess I just don't understand how to know when to put them apart and when to put them separate.
This is, you are asked to find dy over dx. You're not asked to find the differential of y. If you're asked to find the differential of y, exactly. If you're asked to find the differential of y, then you will find f prime of x dx. But if you're asked to find dy over dx, it's very clear you're asked to find f prime, but it's better to use the notation dy over dx because you really don't have the function. And not to get it lost in translation.
Yeah, because I had it separated and I didn't know where to go. I looked at it.
No, you cannot separate if you're asked to find dy over dx. Now, if you're asked to find the differential of y, you will be asked to find dy, which will be f prime of x dx. Paul?
So I went down a different path. Maybe I was wrong.
Yes?
But I was attempting to do the logarithmic differentiation.
You cannot apply log to this.
Same.
You have sine y.
Okay.
Then you will have to differentiate log of sine y.
It seemed like.
Which is not wrong, if you.
Thought that's.
But you cannot apply log to a sum.
So if it was just what, like x sine y, maybe, or x sine x. So the problem is that it's sine y instead of sine x.
No, you cannot apply log to a sum. There is no rule for log applied to a sum. Log applied to a plus b, you're stuck.
Right. So I'm saying.
So when you apply it and you differentiate, then it becomes a little bit more complicated. So you cannot simplify this.
No, what I'm saying, if it was just the first part, like.
Yeah, let's finish this and then we'll apply log to see what happens.
Okay.
Is that the question?
Yes.
Yeah, that's fine. Let's finish this and we'll see what we come up with that. I don't mind. So I have to move this to the other side. So I have sine y minus sine x equals 3y squared minus x cosine y, and everything times dy over dx. Are we in agreement with this? This becomes negative. I have 3y squared minus x cosine y, and these two are on this side. So then dy over dx is sine y minus x over all this. Is this clear so far? Yes. Is this okay? Yes? So this is the final answer. We don't have to do anything else. But now let's say we decide to apply natural log to both sides. Let's see what we get if we do that. Ready?
Well, to this or to something else?
To the original, I thought.
Well, you're saying that that's not the right way to do it.
No, I didn't say that. I said let's take a look and see what we come up with.
Okay.
So are these steps clear?
I
Yes?
just have one quick question.
Yes?
Try that. 'Cause before, you dividing by the dy dx that was multiplied by the cosine, x cosine y, right?
I'm solving for this. This is my variable.
Right.
So I have to divide both sides by the number or expression that multiplies my variable.
She skipped the part, she factored out the,
Okay.
so she brought over, she brought over x cosine y times the
The variable is in these two terms.
Okay.
Yes?
I actually thought the same thing as Paul with the
Yes?
logarithm differentiation.
That's fine. We're going to do it together and see what we come up with.
Well, what I was gonna ask is, does it matter if, the exponent is attached to y as opposed to? So there's a couple of example problems in here, I noticed that only the side with x had the exponent. But this, does that matter?
So the question was if the power is on y or the power is on x.
Yes, so like that problem.
This is a totally different story. Here we have a function raised to a function. If I have a function raised to a number, I go straight ahead to the differentiation rules. But we do not have a differentiation rule for a function raised to another function. In this case, we have no choice but apply natural law.
Okay.
So we'll look at an example like that in a minute as well. Okay, so here we decided for whatever reason, we decided to apply natural log to both sides. We still do that, right? Is that okay? Yes?
Mhm.
Paul, is that what you meant?
Yes.
Is the rest clear now?
Yeah, I'm just writing the middle step. That's all.
Everyone else, before we do that? Other questions? Okay, so let me copy it. X sine y plus cosine x equals y cubed. So for whatever reason, we decided to apply natural log to both sides. So first, before we differentiate, that complicates things because now I have to differentiate a log instead of differentiating whatever I have. That's fine. Let's try. So natural, if we do that, x sine y plus cosine x equals, and I apply natural log to this side, I get 3 a natural log y, right? So the natural log of the left-hand side is 3 natural log y, correct? Okay, so now, after I apply the totally new function, I want to differentiate, right?
Right.
So I'll differentiate this side, and I'll differentiate this side, and let's see what happens. The left-hand side is 1 over x sine y plus cosine x multiplied by this whole thing that I had from before, which is the first function prime times the second function plus the first function times cosine y times dy over dx, and then not plus but minus sine x. And then the right-hand side will be 3, 1 over y times dy over dx. And I complicated things terribly because now I have to take this dy with everything that has with it to the other side so I can factor it out. But first I have to distribute this to sine y and this to this and this to this and then move terms around. So it made it way more difficult. Is that clear? I mean, we can continue, but I have to distribute this to this term, this to this term, and this to this term, and then move the result of this, the term with dy over dx, to the other side. Yes?
So even though it's a lot lengthier, obviously, would it still come to the same answer?
I have no idea. It has to, but I don't know how I'm going to get to it.
Okay.
So it's possible. I mean, I have to get the same answer, but I have to do a lot of algebra. Yes.
Oh, never mind, actually.
No, the answer has to be the same. but I don't know how I'm going to get to it.
The issue is just that we have the function.
So I have sine y over x, sine y plus cosine x, and plus x cosine y over x sine y plus cosine x times dy over dx, minus sine x over x sine y plus cosine x equals 3 over y dy over dx. So now this has to come here. Yeah, the denominator will simplify, so I'm going to get back that. So it should be, I have never done this, no one ever asked. So yeah, so because I see the denominator is the same. When I factor, I have, yes. So eventually I would get the same thing. So these two stay as sine y over x, and then minus sine x over x sine y plus cosine x. And this side will become 3 over y minus x cosine y, x sine y plus cosine x, and times dy over dx. So now I have to find the least common denominator here that will cancel with this in a moment. So then I will have 3x sine y minus 3 cosine x. So dy over dx will be this ratio of this, which is the same thing we got before. Sine y minus cosine x over x sine y plus cosine x.
Did you mean sine x on the top?
Yeah. On the top here.
No, down, right there. No,
So it was sine y minus sine x.
no, down where you're at dy over dx equals. Yes, now move to the right a little bit and up a little bit. Up a little more.
Oh, yes, of course.
There, yes.
Thank you. Sine y minus sine x over the s. And here I have y times x sine y plus cosine x. So now I have a 3x sine y plus 3 cosine x and minus xy cosine y. So let's see what we got before, because these two will go away. So we got sine y minus sine x. Then in order to get this, I have to go back and I simplify 3x. So sine y minus sine x, and the denominator 3. I have to replace y cubed somehow. So I have an x and a sine y. Yes. See, I pull out a 3. So x sine y plus cosine x sine y plus cosine x is 3y cubed. So this piece is 3y cubed and minus xy cosine x cosine y over y. So that's how I get 3y cubed over y, which is 3y squared. And I get the negative x cosine y divided by y, which is negative x cosine y. So it's the same thing, but this one is in 2 rows and this one is in a page and a half.
So basically, don't.
No, because
But not in this case.
because you don't have a function raised to a function.
Yeah, it's when we have a function raised to a function.
Right, that is mandatory. There is no other way. But yes, as you saw, it took us a while and we get the same answer, but we have to go back and replace the function, the equation. Without replacing this term, 3x sine y plus 3 cosine x, 3x sine y plus 3 cosine x by 3y cubed, I will not get the same answer. Very good. Next problem. Here it is, number 7, tangent x raised to x squared. So when we're asked to find dy over dx, if it's an equation, not a function, we don't need to apply log to both sides. Now, if we are given something like this is a function, and I don't have any differentiation rule for a function raised to another function.
Also
If
S.
it were just tangent x raised to the third power, that's fine. It's 3 tangent squared times tangent prime. But this is a function raised to another function, and there is no rule. I have to apply natural log. Now, also you can say, what about here? What if I decide here? That's okay. Here you can apply natural log to both sides, and you simplify. But at the end of the day, you'll still get the same answer, because you have to find the LCD after you finish. So it's not going to, it's going to be straightforward, and you will get the same answer like here. So it's okay. If you want to apply natural log initially, you will get the same thing. But for this type of problem, you're complicating things because here you're only asked to find dy over dx, and you can differentiate implicitly. There is no need to apply log. We get the same answer, but it's much longer. Very good question, actually. No one has ever asked that. You're brilliant. You made me think. Awesome. So we have y equals tangent x raised to x squared. So we are working on this, right? And then I would like to, when you finish, I would like you to work on number 9, which is use differentials to estimate, and the extra credit. So after this one, number 9 and the extra credit. Actually, the extra credit, we did it in class together, but we can do it again. Or we can find other problems. Let me know if you need any help. Yes, correct.
Now I just.
Now you apply implicit differentiation. Correct.
The dy over dx.
Exactly. Now we want to find the dy over dx. Perfect. Yes. You have to, so this is the first function times the second function prime, and natural log prime is 1 over tangent times the inner function prime, which is
Okay, so this is- so this
so the first function prime
yes.
times the
Okay,
second
right.
plus this first function, I don't see it,
Oh, I see.
times log prime times tangent prime.
Uh,
Better? No, but just write the x next to n.
Okay, yeah, not a.
Okay, yes, now you have to solve for this, multiply both sides by y, and replace y by this.
Okay.
Okay, ready? Or not? So I like to do more problems. Paul, do you still have my page 1?
Yep.
You still need it?
Nope.
Thank you. So please write it down. The checklist is due on Wednesday. And when you come back on Wednesday, I don't want you to say I forgot. Please. Because I want to post solutions. Yes.
2y.
So we have natural log y equals x squared times natural log applied to tangent. So far, so good?
Yep.
So then we have 1 over y.
Dy over dx.
Very good.
2x times natural log of tan x plus x squared times 1 over tan x times secant squared x.
Do you all agree so far? So then the final step is dy over dx, which is I have to multiply both sides by y, and I copy y directly. Tangent x raised to x squared, and I copy the rest. Don't do anything. Don't touch anything. There is no need. This is good enough.
What's the 1 over y?
Say it again.
Y becomes the tan x to the x squared.
Oh, that's
We have to replace it. Is that okay, everyone? Any questions? Okay, so let's look at sine 89 degrees. And then I would like to look at other problems. Okay, so what is that very important result that I have to write?
f of x plus delta x
Yes,
equals f of x. F of x plus cos of x dx.
very good. This is it. Again, here how is very easy, I think, to memorize it. F of x plus tiny x is approximately f of x plus tiny y in the form of dy. Okay, so now I have to identify this and this and this, and then I can proceed.
It's the function of sin.
Very good, awesome. Let's also find this right away.
That was
Awesome. So how much is x?
89 degrees.
Careful.
90.
90. How much is the tiny error? -1 degree. And remember, this is nothing else but pi over 180. Perfect. So now I have everything I need. So this part is sine 89 degrees. And now please dictate the other side.
Sine 90 degrees.
for everyone to see first, and then we'll calculate.
All right, plus cosine 90 degrees and then times theta.
Yes, but in the form of, I'm sorry, I should have put a minus, in the form of this. And now we are ready to simplify a little bit, and then we can check.
Now, if the question is in degrees, why then degree?
I can multiply by 1 degree. If it's inside sine, it doesn't matter. But if it's outside sine, I cannot multiply by 1 degree. Yep. Sine 90 is
1
cosine
0.
Yep. Yep, because cosine 90 is 0, and 0 times negative pi over 180 is 0. So in y equals, or I don't need to put any y equals, sine 89 degrees, and I'm still in degrees, I think. So our approximation using differentials gave us 1, and the approximation for sine 89 is 0.99984. Very good. And now I would like to look at more. Bless you. Okay, so here's one. Evaluate dy if y equals x cubed minus 2x squared plus 1. X is 2, and dx equals 0.2. Oh, yes, of course. Why not?
You have the page problem number?
104 on page 267.
This is just like what we did, right? Just the last problem almost.
No, we're asked to find the differential of y. The formula for the differential of y is
3x.
f prime of x dx. So then dy will be 3x squared minus 4x times dx. So now dy equals 3 multiplied by 4 minus 4 times 2 times dx, which is 0.2. Any questions? Any questions? Okay, I'm looking for another problem. And like 87 on 266. Do you have the number for me here? So 12 minus 8 is 4. 4 times 0.2. Very good. Okay, so 87 on 266. An equation of motion of the form S of t is a e to negative ct times, oops, I'll erase this, times cosine of omega t plus delta. Yes?
I missed. Oh, okay, never mind. I'll figure it out.
Very good. So S of t, one more time, is a times e to negative ct cosine omega t plus delta. Represents damped oscillation of an object. Find the velocity and acceleration of the object. Yes, please.
I'm just thinking maybe for the last problem from the notes, Maybe you should write x equals 2.
I think we missed the,
Oh, you had it. Okay.
What was the question? Is it okay? Okay. So we are asked to find the velocity and the acceleration for the given motion. So let's work on this for 1 minute. So we want to find v and a, the velocity and the acceleration. Any questions? Yes. We're not differentiating the constant. The constant stays outside. It's a product. So this is A, it stays outside. This is your first function. This is your second function.
Okay.
So put A outside, let it wait.
So A is a constant, not a
Yeah.
variable.
A. So it's S of t. How many variables do we have in this function?
That's why it looked like
One.
Y.
One. S of t. S of t. We don't know how to differentiate multi functions of multivariables.
Tires on a curveball.
That's why I wrote S of t and find v of t and find a of t. So there's only one variable. Is that clear? Everyone? But it's S of t. Otherwise I would have had S of a, comma c, comma w, comma omega, comma t. So it would have been S of t, omega, delta, a, c. This is a function of 5 variables. But I have S of t. So this makes no sense. Clear? Everything else has to be treated as a constant. This is very important. Is that clear or not?
Yes.
Okay, perfect. Especially when I'm writing find v of t and a of t, right? Okay, very good. Do we need more time on v of t? Is that a yes?
Yes.
Okay, very good. I'll wait. Yes? So what happened to a? Yes?
Okay.
And everything has to be in brackets.
Everything. Yeah.
So if this is a factor out, yes, then everything, okay, that's fine. Yeah, that's
Okay, I
correct.
did double parentheses.
That's
I'm
correct.
sorry.
Yes, that's correct. You're right. Okay, so let's work on v of t together. So s of t is given to us, so then v of t is s prime of t. Agreed?
Yeah.
Very good. So there is a constant outside. This is the first function and this is the second function. I do not have to worry about a. A is a constant, stays outside. I differentiate the first function, I get e to negative ct times negative c multiplied by cosine omega t plus delta plus. Is this clear?
Yes.
I copy the first function e to negative ct and I differentiate the second one, negative sine omega t plus delta multiplied by omega. Delta prime is 0. Omega t prime is omega. I will try to rearrange it a little bit if possible. So both terms have e to negative ct, so I have a e to negative ct, and let's see what is left. I have a negative, and also both are negative, so I'm going to put minus in front. C cosine omega t plus delta, very good.
Plus
Yes?
omega.
Yes. Sine omega t plus delta. Perfect. And this is done. This is the first derivative.
Would it have been wrong if we didn't do that last step?
With a negative?
Just pulling out all of that.
No, it's not incorrect because you have to differentiate again. So it doesn't really matter if you factor it or not because you have to find a of t now.
Because we're not done. So
Yes, that's true. That's fine. It will actually be easier to differentiate this piece and then this one with this, or instead of having the product. So, but this is the final form for the velocity. So it's negative a e to negative ct, and in parentheses c cosine omega t plus delta plus omega sine omega t plus delta. Agreed so far? Okay, so now let's find a of t.
Actually, I guess you just pulled out the negative from the C.
From both
Negative C,
terms.
yeah.
Yeah, both terms are negative, so I pull the negative. So this is v prime of t or s double prime of t, correct? So we can put this back in or leave it as is and differentiate as the first function and the second function, this. It doesn't matter, the answer will be the same. But of course I refuse to do anything with this negative a. Has to wait for us to finish. E to negative ct prime.
E to
It's
negative C.
e to negative ct times negative c multiplied by all this. So multiplied by c cosine omega t plus delta and plus omega sine omega t plus delta. I have to keep my parentheses straight. So this is not a bracket. So let me put different colors here. So this and this.
There you go. Okay, now you're missing it.
Yeah, because I wanted to avoid the whiteout. Okay, so one more time. So we have the negative a stays outside. The derivative of this is this. And I copied all this. Now plus e to negative ct times all this prime. In parentheses again, negative c sine omega t plus delta times omega, very good, plus omega cosine omega t plus delta multiplied by omega. Again, both terms have something in common. And they do have this. So I'll pull it out. Negative a e to negative ct. And let's see what is left. Hopefully something goes away. So negative c times the first term is negative c squared cosine omega t plus delta. And negative c times this is negative c omega sine omega t plus delta. So let's double check what I did. I pulled out a to the negative ct and I distributed negative c to this term and negative c to this term. Now I'm here since this is out, I don't have to distribute anything. So it's negative C sine omega t plus delta. Yes, I'm going to insert, yes, I'm sorry.
Wouldn't you want to do a pull the omega out?
No, because it's only omega in here, but it's not in all of them. It's, yeah. So it's C omega.
Well, wouldn't the C be pulled, the negative C be pulled out? Or I guess that's.
No,
better, yeah.
this is in a
Yeah.
different term. Yeah.
Yep.
So C, negative C omega, and I do have this omega squared. So now I have, what else I have? Yes, so this is negative C omega, and this is omega squared plus omega squared cosine omega t plus delta. So the only thing I can do here is combine these two and pull out another negative. I have cosine sine, and this is cosine. So the first one was cosine. Yeah, this was cosine, this was sine. Yes, and this was sine, and this is cosine. So there's the only thing I can do is combine these two into negative 2c omega, and pull out another negative. But that's good enough. I'm happy with this. Any questions? Okay. We still have, yes, Paul, go ahead.
Is there going to be something similar like this?
What was the difficulty with this, other than it was long?
That's
It was
basically it. Is
Yeah.
there gonna be anything that's long on it?
Well, some of the problems require a little bit more work than
But
others.
I don't think there's anything that's epic.
I didn't write the test yet. So what I'm saying is, what was the difficulty with this, other than a lot of writing?
Still,
I found it confusing.
it gets,
The different constants
Yeah.
to be fair.
yeah, with the.
There is
omega and the
only-
delta.
Yeah, there is only one. I see. I understand what you're saying. Okay, so let's look. This caught my attention. This problem 111. Let's see what it does or what we're asked to do. I know I only have 8 minutes or so. No, 10 minutes. Sorry. Okay, so find f prime. So this is problem 111 on page 267. And we are told this is known. I simply looking at it, I have no idea what will come out of this. So let's give it a shot. So this is the question. It says find the derivative, and this is given to us. Given. That's all it's given. So basically what we are told here is that, forget about this for a moment. Forget about the result for a moment. Let's say we don't know what this is. So when I differentiate f of twice x, I get, so this is like f prime of twice x, right?
It's like 2, right?
So what do I get?
2
I get f of twice x times 2. Do you agree with this?
Yeah.
Right? So the derivative of a function of another function requires the chain rule. So then I get f prime of 2x is f. So the derivative of this, I didn't write it correctly. So df of twice x dx will be f prime. I don't want to write this. It makes no sense. So when I differentiate this, I get f prime of 2x times 2.
Okay.
So I'm asked to find the derivative of a function of 2x. So I have to differentiate the outer function first, and then differentiate the inner. Is this clear?
Yes.
I am also told that this piece equals x squared. So from here, because that's what I'm told, this is given to us, right? So f prime of 2x equals x squared over 2. So now I will pretend that f prime of this, so I will pretend that this is a variable. So this is twice x, but this is x. But I only want x in here. In other words, everywhere in this equation, I will have to replace twice x with x. Or in other words, x with x over 2. So when I have 2x here, I have x. If I have x here, what should I have here? Exactly. So this is x over 2 squared divided by 2. So f prime of x is x squared over 4 divided by 2, which is 8. Now we can go back and verify everything. If this is true, how much will it be if I replace x by twice x? So I will have the f prime of twice x, right, will be replacing in here, going backwards now, I'm replacing x by twice x. So it will be 2x squared divided by 8, which is 4x squared divided by 8. And I'm coming back to x squared over 2. So given this piece of information, we were able to determine f prime. And f prime is x squared over 8. Okay. Any questions? Any questions? Okay, let's look at
I have a question.
yes.
Where did the d over dx go when we, or is it just because you rewrote it?
It's the same thing. This is really the same thing, but I really didn't want to write this because f prime, the derivative of the function of 2x is f prime of 2x times 2. So I didn't like this notation because it's, I mean, I would say it's incorrect, period. So I had to use this in order to explain what I'm doing.
Right,
So
it didn't actually go anywhere. You were just rewriting it.
Yes, but it's not correct. So I should remove it completely. Thank you. So see, the notation is sometimes so important in these problems because otherwise, yeah, so it's kind of difficult to explain this. So it's the derivative of f of 2x, which is the derivative of the outer function is f. So I have to say f prime of 2x times the inner function, which is 2x prime, which is 2. And then we set it equal to this because this was given to us. From here, we solved for f prime of 2x. But this is the function. So whatever I put in here as a new variable, so let's say I denote twice x by y, then x has to be y over 2. So maybe that will be easier to understand. Let y be 2x, which means f prime of y will be, instead of x, I have y over 2. Y over 2 squared over 2, which is exactly what we got. Y squared over 4 over 2, which is 8. And now, because I can write that f prime of y equals y squared over 8, I can also write f prime of x, which is x squared over 8. It's the same thing. No matter what variable I put in x, in f, I can even write f prime of a, which is a squared over 8. Does it make sense? Okay, I know we have 3 minutes. Let me find something quick. Yeah, so for example, express the limit as a derivative and evaluate. Last problem. We had something like this on the checklist. So this is 106 on 267, and we have limit as x approaches 1 from x to the 17th power minus 1 over x minus 1. So it says express this limit as a derivative and then evaluate the derivative. Express the limit as a derivative. So this is the same with f prime of some x. I mean some function, f prime of x. But I have to identify the function. Since its x approaches 1, it's basically f prime of 1. This is similar to f prime of a. This is the definition of the derivative at a particular value. It's not going to be a function, it's going to be a number. So, which function we are looking at? So I can differentiate it and then plug in 1. Okay, let me refresh your memory. F prime of a is the limit as x approaches a from f of x minus f of a divided by x minus a. We also have the other form, but that's not the case. It says x approaches. So we have the other form with h approaches 0 from f of a plus h minus f of a divided by h. But this is not the case because, go ahead.
X to the 17th power minus 1. Minus 1.
So f of x is x to the 17th. F of 1 is 1. Denominator x minus 1. So the function is x to the 17th. So then f prime of x is 17x to the 16th. And therefore f prime of 1 must be, that's it. Does it make sense?